In reviewing inequalities, we need to really think about what are some of the big ideas. So some of the big ideas are going to be, do we understand the difference between a one variable inequality or a two variable inequality? And we need to make sure that we understand what the boundaries are for a one variable versus two variable, and boundaries are the key. So for one variable inequality, we need to have the solution in one dimension or along the number line. Okay, and if we graph it and use an XY graph, we need to understand that we can see above or below the x-axis, but our solution is going to be along the number line or in one dimension. A two variable inequality has a two-dimensional solution or an area solution. Okay, so we want to make sure we understand that the boundary is going to be, instead of the intercepts, it's going to be the line, the actual function, and then we're looking up either above or below that function. So we also need to know how to draw functions to be able to do this with and without technology. So we need to be able to draw a linear function using either slope-intercept form, or we can also draw linear functions using the x and y intercepts. With quadratic functions, we need to make sure we know how to draw these quadratic functions as well. So vertex is key. We also need some symmetrical points, so zeros are very useful. So if you have factored form, we want to use the factored form. And then there's some other issues such as testing. Okay, so if we test, we can solve inequalities by testing. And for one variable quadratic inequalities, testing is probably the most reliable, because the other method is sign analysis, which we'll get into. But the testing for quadratic linear inequalities, or one variable inequalities, quadratic one variable inequalities, testing is probably a very efficient method to use. And we also need to use, we can also solve two variable inequalities by looking at above or below. Okay? So we can look at above or below the function to be able to solve a two variable inequality. So let's do some of these problems here. So here is a one variable inequality. We can graph this. We have 2x minus 5. Okay, and we want to know the boundary, and we want to know where the graph is below that 0. Okay, so it's going to be this area here. So the key is the 0. We can solve these algebraically very easily. So we solve this by adding 5 to both sides, dividing by 2. So we know that the boundary is 5 over 2, or 2.5, and we know that the solution is to the left. So our solution can be shown as an inequality like that, or we can show the solution on a number line. Again, keep it open because it's not equal to, and then we can show that on the number line. For the quadratic one variable inequality, it's a little bit harder to do because we do have two zeros and we have multiple regions that we could test. Okay, so we can look at this in terms of a graph as well. So looking at this, we're probably going to, first of all, write this as a quadratic that is equal to 0. This way we can factor it. So I'm just going to, on the side here, factor. So I have 3x squared, negative 5. So that becomes negative 15x squared. And so we're looking at two numbers that multiply to negative 15 and add to negative 2. Well, that's going to be negative 5 and positive 3. So we end up with 3x minus 5 and x plus 1. Okay, so if we're going to solve this, then we can determine our boundary regions based on our zeros. So we have a 0 at negative 1. And we're going to color that in because it's equal to that boundary. And we have 0 at positive 5 over 3. And we're going to color that in. And we want to know where this inequality is above 0. So we could test. And the testing is fairly reliable. And the easiest number to test is always going to be 0. So 0 represents a point in the region. So if I plug in 0, I get negative 5 times. So that's going to be negative 5 times positive 1. That's going to be negative 5 is not greater than 0. So that is not part of our boundary region. Sorry, that's not part of our solution region. So we know that we can have our solution going out in this direction. We could also analyze this problem in terms of the quadratic graph. So if I draw this graph, we have zeros at these 2 points. Okay, and I know this is a parabola opening up. Okay, and I know that I'm looking for the area of this graph bigger than 0. Okay, bigger than 0 is going to be above the x-axis here. And again, that confirms that we are in the right boundary, we have the right area for our solution region along the number line. Again, it being one variable, we have to show that the solution is along the number line. So two variable inequalities are different in that we have our solutions are going to be shown as an area. So when we graph these, so graphing these on a graphing tool, okay, we won't have Desmos on the calculator on the test, but you will need to at least have the skill of being able to analyze a graph. Okay, so if I'm going to graph this, I end up with negative 2x squared minus 4x plus 5. So our graph is going to be an upside down parabola, and I'm going to draw it with a solid line. Okay, so it's going to be a solid line. The vertex is going to be around here. Now, since it's a two variable inequality, I am not looking at the intercepts as my boundary. I'm looking at the line as my boundary. And it says test a point that satisfies the inequality. Well, it looks like, again, 0, 0 is a nice point to test. Okay, so 0, 0. I'm going to test the coordinate 0, 0, and I need to test both the x and y. So 0 is less than or equal to 0 minus 0 plus 5. That's true. So our test confirms that this is the right area. So we are looking at all this area bounded by that line, or the area below the boundary line. Okay, so there's our solution region. And every point that we test in that region should work. Every point outside the region does not work, does not satisfy the inequality. For this one here, we're going to graph this. Our graph is a right side up parabola. Change that axis to a different color. Okay, so this is the vertex is going to be at 2, negative 7. Okay, and let's just make sure that we know the shape of this. So we know the vertex, which gives us pretty much what the graph looks like. I'm just going to graph it anyway just to make sure that we have a good shape here. It looks like it crosses almost at the x-axis. And I'm going to draw this as, sorry, at the origin. And I'm going to draw this as a dotted line. Now, when we look at this inequality, it says y is greater than, so we should expect the solution to be above this line. Okay, so I'm going to test a point which I know is above the line. So that it's hard to kind of see that, so that if that 0, 0 is included. So I'm just going to choose this point here. I'm going to use 2, 0. So substituting that in, y is greater than, 0 is greater than 2 times 2 minus 2 squared minus 7. So 0 is greater than negative 7. That's check, so we can see that above does work as our solution region. Okay? And again, if I test at some point under that is outside here or below, none of those points will work. We could check to see if 0, 0 is in fact part of the solution region. We can check 0, 0. Okay, so we can test 0, 0. Okay, and we end up with 0 is greater than 2 times negative 2 squared minus 7. Well, 2 times negative 2 squared is 8, so 0 is greater than 1. That's not true. So it looks like that is just on that side there. So the intercept or the origin is just on the below that dotted line.